Hi guys, this is the video for the 4 extra practice problems. These are the problems that you have on your worksheet, and they're also the problems that are on the practice on McGraw-Hill. I did not like McGraw-Hill's questions, so I made my own. Here we go. Okay, so what you're going to be doing for each of these is you're going to write a linear equation, a y equals mx plus b for each one, and then you're going to compare the rates of change and the initial value. I'll show you what I mean. Now, you don't get freaked out about this graph. I know there's no points on it. You can figure out where the points go, okay? And I'll show you how to figure that out. All right, so for example, the first thing I check is to see if the line intersects the x or the y axis at any exact point. That happens to be an exact crossing point. See how that goes across there and it intersects right there? That's an exact crossing point. This is not. It's on a line, not. The only other place it intersects is here, and then again down here. All right, so those are the 3 points we have to work with on this line. Okay, so the first thing we need is slope. We can move from any of the left points to any of the right points to find the slope. If I start from this one, you remember the first move is always up or down. So this is down 1, down 2, down 3, down 4, down 5. So my slope is down 5 and then right 1. So the simplest way to write that slope is -5. Okay, so starting off with y equals -5x. Where's my y-intercept? My y-intercept is right here, but this isn't numbered. What number is that? It's okay, this is 0 here. So this would be -1, -2, -3, -4, -5. So the y-intercept is at -5. This is the equation that represents this graph. Okay. Going over to the table, all right? I need a slope and a y-intercept. Remember, the slope is always the change in y over the change in x, right? How is x changing? X is going up by 1 each time. How is y changing? It's going up by 4 each time. So if I put the change in y over the change in x, the simplest way to write that is 4. So starting my equation, I have y equals 4x. Now, what would be the initial value for this one? All right. Well, in order to find the initial value, we need to know what y is when x is 0. But x isn't 0 on this graph. So we're going to have to add a row here. This is going down by 1, down by 1, down by 1. So we go down by 1 and we get 0 here. Going from bottom to top here, we go down by 4, down by 4, down by 4. If we go down by 4 again, we get 0. All right, so that tells me the y-intercept of this equation is at 0. So I'm not going to put a plus or a minus over here, okay? But keep in mind that it is plus 0, okay? So let's compare the rates of change. Here's where it gets interesting. This one has a rate of change of -5. This one has a rate of change of 4. If I gave you -5 and 4 and asked you which one was greater, you would tell me 4, because you have been taught that negative numbers are less than positive numbers. But in slope, negative just tells us direction. It's not the same as a negative number. It means that this is a downhill line and this would be an uphill line, okay? What we're asking is which one is slopier, okay? It doesn't matter if it's going up or down, which one's steeper, okay? And in this case, the -5 is the steeper one. So the graph has the greater rate of change. Even though it's negative, it's still steeper. Okay. So the graph has the greater rate of change here. Which has the greatest initial value? The initial value is your y. This one has an initial value of -5. This one has an initial value of 0. Now here, you do pay attention to negatives. This -5 is less than 0. So this one has the greater initial value. So the table has the greater initial value. I won't write these all out in the future. I just want to make a point here. All right. Now, on these problems in McGraw-Hill, some of them I only ask you to compare the rate of change, and some of them I ask you to compare both. Okay. I don't think this one asked you to compare initial value on this one. It was just the rate of change. Okay. Let's look at another example. Okay. Again, I know it's a graph with no numbers and no dots. Find your dots. This is clearly a dot. Travel along the line until you find an exact crossing point. See this right here? That's an exact crossing point. See how it lands right where these two pieces of grid cross? You could have also gone this way and find an exact crossing point here. Okay, so now we have dots. So to write the equation, we need the slope. Remember, slope is rise over run. Go from a left point to the right point. Rise up 1 and right 2. So up 1, right 2 gives us a slope of positive 1/2. That's our slope. What's our y-intercept? Right here, 0. That's our y-intercept. Over here, we need a slope. How is x changing? Up by 3, up by 3, up by 3. How is y changing? Up by 1, up by 1, up by 1. Put the change in y over the change in x. This one has a slope of 1/3. Okay, what about initial value? Well, we need to know when x is 0, what is y? Okay, well here, if we're going backwards, we would go down by 3, down by 3, down by 3. Down by 3 takes us to 0. How is this one changing? Down by 1, down by 1, down by 1. So if I go down 1 from 3, I get 2, which means this one has an initial value of positive 2. So this is the equation for the table. This is the equation for the graph. Which one has the greater rate of change? Which one has the greater slope? Well, we don't pay attention to positive and negative signs when we're comparing slopes because it's just direction. So which is the bigger number, 1/2 or 1/3? Well, if you had a pizza that you really liked, would you rather have a half of it or a third of it? I think you'd rather have a half. So that means that this one has the greater rate of change. Greater rate of change is the graph. Which one has the greater initial value? This one has an initial value of positive 2. This one has an initial value of 0. So this one has the greater initial value. That's this one. Okay, so let's see if we can find some points on this line. Traveling along the line, that looks like an exact crossing point right there. And that looks like an exact crossing point right there. Okay. Y-intercept, not easy to tell. Okay. So this is not one where I'm going to ask you to compare initial values because, well, you could obviously tell which one this is, but this one's negative, so this one's going to have a greater initial value because it's positive. But this one, I'm only going to ask you for rate of change. So when you're looking at an equation, the rate of change is this number right here. So that's easy. That's done for us. What about this one, though? To get from this point to this point, we go down 1, 2, 3. So down 3 and right 2. Okay? Well, this is actually mathematically equal to 1 1/2. So when we're comparing which one's greater, which is greater, negative 1 1/2 or negative 2? Remember, when we're talking about slope, negative doesn't matter. Okay? You're just comparing the numbers to see which one's steeper. Is 2 bigger than 1 1/2? Yes, it is. So this one is steeper. It has the greater rate of change. Okay? The equation does. Because 2 is more than 1 1/2. All right, this one has a word problem. A car begins a road trip 50 miles from home and travels at a rate of 60 miles per hour. They've given you the rate of change. That's negative 60 because it's traveling at negative 60 miles an hour. No, not 60. I was thinking this was like the one where the girl was decreasing her distance. That's not what this is. We're trying to see how far away it's going to be. So the car is traveling 60 miles an hour, and it starts 50 miles from home. Okay? So now we have equations for both. Which one has the greater rate of change? Which is greater, 45 or 60? 60 is bigger, so this has the greater rate of change. Which one has the greater initial value? This one starts at 50. This one starts at 55. This one has the greater initial value. Okay. Greater rate of change. Again, we need to write an equation for this one. A school bus departs, this is the one I was thinking we were on, departs for field trip 70 miles from its destination and travels at a rate of 55 miles an hour. See, they're saying the trip is 70 miles an hour, 70 miles. So 55 miles an hour is going to be negative because every hour that you travel, you will get rid of 55 miles of your distance. All right, and the initial distance is 70. Okay. So, which one has the greater rate of change? Remember, when you're comparing slope, negative is just a direction. You need to know which number is bigger, 60 or 55. 60 is bigger, so the equation has the greater rate of change. Which one has the greater initial value? Comparing 70 and 65, this one has the greater initial value. The equation, or the word problem does. All right, so let's see. A bicyclist leaves home and travels 14 miles per hour. So leaving home is sort of like home base, so we're not going to have an initial value on this one. The initial value would be 0. Bicyclist is traveling 14 miles per hour, so we're going to have y equals 14x. That is our rate of change. All right, if you were going to have an initial value, it would be plus 0. Over here, we have how fast is this one going? In 1 hour, they traveled 12 miles. Okay, so this one is traveling 12 miles an hour, and the initial value was 10. Whatever y is when x is 0, that's your initial value. Which one has the greater rate of change? Which number is bigger, 14 or 12? This one has the greater rate of change. Which one has the greater initial value? This one does. Greater initial value goes to the table. Are you having fun yet? I know I'm having a blast. The kids in my study hall are thinking this is great times too. Yeah, some of them are asleep though, I think. Okay, so we're getting there. Write equations for both. All right, we have an afternoon walk. We have distance in miles. We have no dots, but we do have numbers this time. Here's one exact crossing point, and you'll notice that you have exact crossing points at every intersection. Just like that. Okay, there are lots of them. So when we go to write the equation for this one, the first thing we need is slope. So if we go up 3 and right 1, up 3, I said 3 because of the way it's numbered, right 1. Okay, so our slope is 3 over 1, which is the slope of 3. All right, that means we're going 3 miles every 1 hour. Okay, and then what's our initial value? Well, our initial value, this is going down by 3, right? So our initial value is 0. That's where it intersects the y-axis at 0. So over here, we have another equation. Which one of these has the greater rate of change? You're comparing slopes. Which slope has the bigger number, 3 or 2.5? 3 is bigger, so this one has the greater rate of change. And which one has the greater initial value? This one has positive 5, and this one has positive 0, so this one has the greater initial value. We're getting there. Oh, we're done. Okay, so those are the problems that are on your paper practice, and they're also the problems that are on McGraw-Hill. So I hope you wrote them all down on your paper practice so that you can refer to that when you're solving it on McGraw-Hill. And in the meantime, have a great day, and I will see you in class.